Hey everybody, so we've gotten to lab time. I'm so excited. So let's jump right into it. We're going to start with the first lab of potions class, and that is going to be our Elixir Euphoria potion. For the materials, we have a box of baking soda. Here. We have one bottle of vinegar, with food coloring added to it. And ultimately, we know that we need a third of a cup. So I actually measured that out already. You can see the graduated measurements right there, right? So you see a third. We try to follow it right there. So I measured that out already. So we have a third of our cup of vinegar with the food coloring, red food coloring added to it. We have one disposable plastic glove. I did already draw my face on it right there. Nice little smiley face. And a plastic cup, which is what we see here, our color markers that we drew our face on, and then a thermometer. I do not have access to a lab thermometer that would be appropriate for this lab. I tried with a household thermometer, but it would not read a temperature reading. So you'll see how we handle that within the experimental design. Number one step of our procedure says to draw on a hand or any other design you want on the glove. So I just did a simple little smiley face, which is what we see here. Hi there, say hi. So happy to see you. We then have to, number two, place 3 to 4 tablespoons of baking soda in the glove. So I used my handy dandy little measuring cup. If you look at the measurements, they also are listed in tablespoons and quarter cups. So I measured out roughly about 3.5 tablespoons of baking soda, and I did place it, as you see, at the bottom of my gloves here. Making sure the baking soda, and then we're going to pour 1/3 of a cup of vinegar in the plastic cup and take its temperature. So in lieu of having a thermometer, what I can tell you is that this vinegar was out at room temperature for the greater part of its time in my household. So we'll say that the initial temperature reading was about 70 degrees Fahrenheit. Okay, so you can note that. Step number 4, making sure the baking soda doesn't mix with the vinegar. Place the glove over the plastic cup. So here comes the slightly tricky part. Okay, I'm going to place that all the way on as far as I can without mixing the two components. Okay. And then it says once the glove is secured over the cup, empty the contents into the cup and watch what happens. Then take the temperature again, right? So we'll just note if there's been an increase or a decrease in temperature. Okay, so on the count of 3, let's take all of our fingers full of baking soda. 1, 2, and then I'll just show you what I see here. We have my little happy face that's inflated. And we see lots of bubbles, lots of bubbles, lots of bubbles. Happy face that's still inflated, full of something. I wonder what happened there. Okay, what I can tell you, as my fingers, very safely going to see if it's safe to touch. And if I touch this, it is not room temperature anymore. In fact, even through the glove where it seeped out, I can feel that it's gotten a significant amount colder. So the temperature, we may not be able to note an exact initial and final temperature, but I can say that there has been a temperature decrease, most certainly. So make sure that you mark that somewhere in your observation workspaces as well. Okay, so absolutely a dip in temperature. The temperature has lowered. And we see that our little guy has remained inflated. Okay, I'll raise my webcam again. We see that it has remained inflated. So there is something to that as well. Okay, what occurred throughout the process of this chemical reaction that, well, what we ultimately know is a gas was produced. Something was produced, a certain kind of gas, which then inflated and expanded the quote-unquote container that it seeped into. Okay, so let's take your observations. I'll leave it up for a couple more seconds. Note the colors. There's the baking soda at the bottom there, your liquid right? Do you think that the components would be the same at this point? What kind of changes? What have you noticed, formed, occurred? And make sure you're putting all of that in your observation workspace. Okay, so I'll be back with the next experiment. Okay, everybody, I'm back. We're doing Felix Felicis potion now. So this one requires this has 1 to 8 Alka-Seltzer tablets. So I just have a pack of 2. Water mixed with food coloring. So, and in particular, we eventually find out that it is a 1/4 cup of water. So I have my 1/4 cup of water, as you see there. Okay, I'm trying not to move so that you can see that it is a 1/4 cup. Okay. Fill with food coloring. We need oil, or our spine of lionfish fluid, which is right here. And we eventually find out that we need 1 cup of that. And 1 to 8 small water bottles. So I have my 1 little water bottle for myself. A funnel right here. Okay. And a flashlight. And I'm just going to be using my phone for my flashlight. So it says to pour 1 cup of oil into the bottle. And use the funnel not to spill. So here I have my bottle. I'm going to insert my funnel. Okay, I'm just going to place it upright that you guys can ultimately see. And I'm going to take my oil and I'm going to begin to pour it into the bottle. So you should see it filling up now. About 1 cup of oil being poured in there, right? So make sure you're taking observations at all stages, okay? I can tell you there's no chemical reaction happening quite yet, right? We've just transferred one of our reactants, okay? So I'm going to put my funnel to the side. Then says to pour 1/4 cup of water into the bottle using the funnel not to spill. So I'll place my funnel back inside. And now I'm going to take my 1/4 cup of green water and also pour that inside. And we want you to note and look at what that looks like. Right? And pour some more in. Okay, how do you see how that water is or is not mingling with the oil? What does it look like? What does it look like? Okay. We're just mixing these together. This would be that classic example of a suspension, guys. Every time we talk about a suspension, do you see what's sort of lingering at the top even of our oil? We have how the oil and the water do not mix. So one is almost suspended, hanging in the other. Okay, we don't have that solution effect, right? Where they beautifully dissolve and you can't really tell where the salt water begins or the water begins. It's all beautifully intermingled. Here you can really, make out those distinct components despite the fact that they are mixed together. So here we have my oil, or our oil and water mixed together. So I'll place that nicely there. Next step says to pour several drops of food coloring. Okay, so we did that already with the water. And then drop the Alka-Seltzer tablet into the bottle and close the top and observe what happens. So let's take our Alka-Seltzer tablet. Okay, show you guys that up close. So this is what an Alka-Seltzer tablet looks like. You can almost make out the words Alka-Seltzer. And it says to drop it in and then close the top. And I can tell you right now, I'm going to have to cut this in half slightly just to get it in at the same time. So I'm just going to pinch it like that. So on the count of 3, 1, 2, 3. And what do you see sort of happening? Right? Kind of crazy. You hear that creaking sound? That's the walls of the bottle expanding from a slightly crinkled state, completely expanding. It says to hold the flashlight to the bottom so you can kind of see what's going on. If you notice, the particles are actually moving up and then back down. They're moving up and then back down. Do you see how some are moving up and others are moving down? Kind of reminds me a bit of a lava lamp, to be honest with you. Right? I think that's pretty incredible to see. Okay, awesome, guys. If you need to replay it, definitely do that. Okay, I could tell you right now, the walls of the bottle are extremely rigid. There is no give anymore. If I try, and I'm not actually going to do it too much, if I try to press on the walls, it's not possible to collapse the walls anymore. It is so expanded. I want you to look at the bottom. The bottom has even collapsed out. Or I shouldn't say collapsed out, it's expanded outwards. See how it's not even a flat bottom anymore. Okay, so it's almost hard to balance at this point. Okay, let me see if I can try to collapse it, and maybe you can hear a certain sound. Kind of sounds like it does when you open up a bottle of soda. Okay, and you still see those materials rising and falling. They have not stopped this entire time. They are still rising and falling. You see, they almost gather towards the center and they move up. And then towards the outside, they move back down and back up. Okay, guys, so take all your observations in your observation workspace and get geared up for the second lab, guys. Good job. So, on to the wit potion. So for these materials, we will need 1 jar of yeast or powdered dragon scales. So our yeast is right here. Okay. We are going to need 1 bottle of hydrogen peroxide. I have 40 volume. You can get this from a salon store. Okay. You will need food coloring. Bam. 1 cup of dish soap. Okay, so 1 cup of dish soap, and I just have my bottle here of dish soap. Dawn, classic. And then 1 plastic cup, and I just have a styrofoam cup. Ultimately, the material doesn't matter too much. You need 1 glass flask or small, narrow glass jar, which is right here. Okay. Goggles and a thermometer. And again, because I don't have a lab grade thermometer, I'm just going to describe that the initial temperature of all these materials is going to be around room temperature. So it's going to be about 70 degrees Fahrenheit. So you can note that as your initial temperature. And then I will just generally indicate whether or not I feel an increase in temperature or a decrease in temperature. And you can put that in your observation workspace, as well as in any portion of the data that requires you to note a temperature. So step 1, put on your goggles. I do have those on. This is definitely an experiment you do not want to ignore that with, because it is slightly explosive. And amongst the other bits of things that you are going to observe, you definitely need goggles. You need about a half cup of hydrogen peroxide poured into your glass flask or jar. So here I go. I'm going to open up my hydrogen peroxide, and I'm going to pour half a cup. Half a cup. I always think that smell is so crummy. So half a cup. Okay. So half a cup of hydrogen peroxide. I'm going to place that on the floor now. We'll not be needing that for the duration of the experiment. So here's my half a cup of hydrogen peroxide, and I'm going to pour that into my glass jar. Okay, so half a cup of hydrogen peroxide in there. Next thing that I'm going to do is pour, so again, 70 degrees Fahrenheit roughly. Combine 3 tablespoons of warm water. So here is my 3 tablespoons. Actually, it's about 4, so let me measure out precisely 3. Is that 3 yet? Nope, we're still at 4, Mrs. Jordan. Is that around 3? That is almost exactly 3. Combine this with 1 tablespoon or packet of active dry yeast and a cup. So here we go, pouring my warm water with my active dry yeast, which is right here. I'm going to grab some scissors. Just cut across there and combine that. Closer. Okay. Try to get as much as possible out. And that's what we look like right now. So I'm going to take my little straw that I'm using as my mixer, and I'm going to mix that, what it says, for about 30 seconds. Okay, I want to get all the sort of congealed parts, get it nice and mixed. Get it rocking and rolling. Right, you want to do this as close as possible to the point of being added to our hydrogen peroxide. So you don't want to prep these materials too far in advance, which is why I'm doing it live with you. Okay, so I think that's pretty mixed. Okay, that's my 3 tablespoons of warm water and active dry yeast. Then it says to put about 8 drops of food coloring in here into our hydrogen peroxide. Okay. Again, you can give it a little swirl to get your hydrogen peroxide and green food colored mixed, and a tablespoon of dish soap. So now I have my empty measuring cup, and I can put my tablespoon of dish soap in there. I went a little out of order to the procedure, but ultimately I made sure not to mix the 2 separate mixtures, because these are mixtures, right? Everything is just no chemical reaction yet. This is a solution of food coloring and water. The particles are just evenly dispersed. So again, it's a mixture, not chemical combination. I'm adding yet something else. Okay. Still not too much going on. Okay, so I'm just adding my dish soap to the hydrogen peroxide and food coloring mixture. Now we just have a dish soap, hydrogen peroxide, and food coloring mixture. And now what we are going to do, it says, pour the powdered yeast mixture from the cup into the glass flask or jar using a funnel and stand back. So I don't think we necessarily have to stand back, but we do have to be careful. So 1, 2, you note what is coming off the top. Okay, not sure you can quite see, but I'll tell you right now, there is smoke coming off the top of this. Okay, there is smoke coming off of that. I'm trying to see if I can position it so you can see some of the smoke against me. Okay, there's quite a bit of smoke. coming off the top of that mixture. And as you see, something certainly formed. Okay, so take a look. Make sure you note what you see. There's a ginormous bubble right over here. I can tell you right now as I place my hands against it, it is quite hot. Okay, quite hot. Definitely a significant increase in temperature from where we started. And we definitely have a different end substance than the two that we started with, the two mixtures that we started with. Okay, look at the different bubbles all over the place, all the different bubbles. Note all of this in your observation workspace. Okay, so get that all done. We'll finish up with the last experiment in a bit. Class, I can't believe our time together at Hogwarts is coming to an end. But we are making some polyjuice potion, which is pretty cool. The materials for this experiment is a petri dish, 1/2 cup of dish soap or essence of belladonna, 1 pint of milk or Pegasus tears, food coloring blue. So we have some here. Okay. Red, which is bat blood here. Food coloring. And then a cotton swab or magic wand. And again, I do not have access to a lab grade thermometer, so I will just note initial temperature. The initial temperature of the milk, which is step number 1, take the temperature of the milk inside its container, then pour some milk onto the petri dish and fill halfway. This milk was in my fridge, so I would say it's roughly, probably about maybe 34 degrees. Okay, so you can note that as your initial temperature. It's quite cold. So let's fill my petri dish, as it says, about halfway. Probably gonna make a mess, but we're gonna try our best. Actually, I'm gonna do it over. Okay, we're definitely gonna make a mess, but I'm gonna try. Almost about halfway. Okay. That's why I love science. You can make a mess and no one cares. Or they'd care, like you just clean it up. Okay, so here is, we'll put the milk down. Here is our half-filled cup of, or half-filled petri dish of milk. Okay, there we go. Let the camera refocus back on that. Wave out my area a little bit. I don't want you guys to be distracted. Okay, so take the temperature again. I would say about 34 degrees. Pour a few drops of food coloring onto the milk and take the temperature. So again, 3, 4, and then 4. Okay, so you can know what that looks like. It basically just spread out. And it doesn't feel any sort of significantly different to me. So I would just say same temperature. Okay. Now it says dip a cotton swab into the dish soap, enough to get the tip covered but not dripping wet. So here is my dish soap. Here's my cotton swab. Okay. Back it up a little bit. So I'm going to dip it in, and you don't want it dripping wet. Okay, so that's not going to do. We don't want it to drip too much, right? So we can just sort of tap it. Don't want it dripping again. Okay, I think that's pretty good. Covered, saturated, but not dripping in any way. Now it says to touch the mixture of milk and food coloring with the wet tip of the cotton swab or wand and watch what happens. Then take its temperature. So what I'm going to do is I'm actually going to grab the webcam then I'm going to bring it down even closer to my milk and food coloring. Okay, so 1, 2. Great, so you should be taking some observations and noting what's happening. Okay. Right, it's almost like it's moving outwards from the entry point of the Q-tip. Okay, I'll let you watch it a little bit longer. Still moving. All of that darker color is sort of pulling towards the outer edges. And then it says to take the temperature. So what I'll do is I will feel, see if I can note anything. And while I do that, let me again just face that downwardly so that you can see. Okay. Okay. So you still see there's almost a pocket here that's forming, right? There's almost a pocket there that's forming. Okay. Okay. I'm just trying to look up one thing. So I feel like the temperature change is very, very, very subtle, if any. Okay. I don't quite notice any sort of temperature change, so we'll revisit that together once I get some more information. Okie dokie, so make your observations, and then we'll come together as a group and talk, okay? It's definitely still moving, though, if you look up close. More soap to the milk. I actually did notice that there was a more significant raise in temperature. Again, nowhere near what I would even consider, warm or certainly not hot, but there is definitely a higher temperature that I feel than what I would have initially felt out of milk taken directly out of a refrigerator. So I would note that the general temperature increased with the combination of the soap with the milk. Okay, and we're going to be looking into perhaps why that occurs. Okay, thank you.